All right. Midsegment theorem and coordinate proof. Midsegment theorem you'll see quite a lot for this chapter, so get comfortable with it and get comfortable with how it works. It's not super difficult to understand. Would one of you read the definition of a midsegment of a triangle?
A midsegment of a triangle is a segment that connects the midpoint of two sides of the triangle. Every triangle has three midsegments.
So in other words, the midsegment is this portion right here, M to P, because it's connecting the midpoint between this line and the midpoint between this line. Okay? But there are also other ones. You have this midsegment connecting the midpoint of this line and this line. And then you have this midsegment connecting this line and this line. Okay? The key word, the key part to hear this is when you hear midsegment or midpoint, you know that for a fact that it's exactly in the middle of whatever it's talking about. Okay? So we can use that to prove things, to prove measurements and lengths and things. So for instance, Theorem 5.1 is the midsegment theorem. Make sure that's in your journals. The segment connecting the midpoints of two sides of a triangle is parallel to the third side. So in any case of those, in this case, this midsegment, since it's connecting this side to this side, then it's parallel to this bottom side. And the mathematical side of it, it is half as long as that side. So I can look at this and go that this measurement, DE, is half as long as AC. So if they gave me either measurement, I could solve for the other one. So if I know that AC equals 4, then I know that DE would equal half of that, which is 2. Okay, and vice versa. So this is how you're going to use it to mathematically solve. So let's look at example 1. Put this in your journals. All right, we have looks like a construction. Yeah, triangles are used for strength in roof trusses. In the diagram, UV and VW are midsegments. So UV and VW are midsegments of triangle RST. Find out what UV equals and RS equals. Okay, so what measurement do we already have?
VW.
We have RT, right? Oh, we do have VW as well. We have VW. Well, RT, why is that one important?
Because you can have it.
Yes, because RT would be double the size of UV, right? Mm-hmm. So I could say UV equals 1/2 of RT, which is the same as saying 1/2 times 90. And what's 1/2 of 90?
45.
45. So UV is 45 inches. Okay, and then she said earlier, we know the measurement of VW, and we're trying to find RS. Well, what is VW compared to RS? Half of it. Or if we're trying to go the reverse route, I would say 2 of VW is what RS would equal. So I'm going to say 2 times that 57. And what's 57 times 2? 114. So RS would equal 114 inches. So everybody see how we solved that? We went both ways. We went where we had the longer measurement and we divided it by 2, and we had the shorter measurement and we multiplied it times 2. Not too bad, right? All right, let's look at example 2. All right, so we have a kaleidoscope. This should be interesting to try and draw on. In the kaleidoscope, we have segment AE. I don't even know what color to use. AE, short segment here, is congruent to BE. Okay, so I can mark it like this with the little red tick mark. And AD is congruent to CD. So again, you can mark it with two little tick marks. So that measure is equal to that one. Show that CB is parallel to DE. So they want to see that CB is parallel to DE. Okay? So how would we know that? Don't read the answer, just tell me verbally.
Since the segments on either side of D and E are congruent to each other,
Mhm.
they're the midpoints.
This would be the midpoint. Same on this side. Because we know that the two sides on either side of that midpoint are congruent, we know that's directly in the middle. And if you have a line that connects two midpoints, then the third line is parallel. What theorem was that?
5.1.
Theorem 5.1. Beautiful. Normally you would have written down everything we just said, but any other questions? All right, coordinate proof was one of your vocab words. Somebody tell me what a coordinate proof involves.
Involves placing geometric figures in a coordinate plane.
Yes. And then you're going to use variables to represent the coordinates in that proof. So let's look at example 3. We're going to place the figure in a coordinate plane in a way that it's convenient for finding side lengths. So if I have a coordinate plane, I'm going to go grab one of my graphs. Lame. Okay, I'm just going to draw it. My graph is gone. I'm going to put an A. We're supposed to do a rectangle. I'm going to put this in the graph. Where's the quickest, easiest way to start this rectangle so that it's easy to measure? If I'm going up this way, I would put it touching the origin, right? Because it's 0. So then we just got to count. If I were to start my rectangle way over here, that'd be weird, right? Or if I were to draw it right here in the middle, then I got to count and go all these crazy places. If you just start it in the origin, it's simple. So it says, and assign coordinates to each vertex. So it didn't give me a measure, so I'm just going to go over and then up and then back. Okay, so now I have coordinates that I can put for each vertex. So the first one's easy. It's at 0, 0, right? The next one, I've put the lines in here, but if you didn't have the lines, you would just say, give it a variable. They gave it h. And then we do know that the y value is 0 because we didn't go up at all. If I were to go up, I know my x value is 0. And then if I didn't have the lines here, you would just give it a letter value. And they like using k. And then this last one would be as far as h going over and k going up. Does it really matter what variables you use in here? No. And usually you would have to start out by saying h represents the length and k represents the width. Why they didn't use L and W, I don't know, because that would make more sense to me. Okay, so now I've put in a rectangle in a coordinate plane. Make sure you have this in your journals. This is A. And yes, I want you to sketch it. All right, so now we're going to do the same thing with B. The difference with B is that it is a, what are we drawing? A scaling triangle. So again, I have my coordinate plane, and I'm going to start in the origin again. And this time, I'm going to go keep my base here. What's a scaling triangle look like?
They don't
none of the side lengths would be equal. So I need to be a little awkward with it. So I'm going to go not quite all the way and then this way. So that way the lengths don't equal each other. And then to label it, again, I have 0, 0. And then over here I have 0, sorry. And it doesn't matter what variable I put. What variable do you want to put here? M, sounds good. M comma 0, because my y is 0. And then up here, I went over and up, so I'm just going to put 2 variables for that. And again, it doesn't matter which variables, so I'm going to put S and T. It doesn't matter. So now I've drawn a scalene triangle and labeled everything I could. Simple. All right, so now let's look at example 4. We're going to place an isosceles right triangle, isosceles right triangle in a coordinate plane. Then find the length of the hypotenuse and the coordinates of its midpoint. Woo, this will be fun. So again, since we're placing it in a coordinate, if I could draw a straight line, that would help. Right triangle, what does isosceles mean? Two sides equal the same. So however far I go this way, I have to go the same distance that way. Okay, and then connect them. So we know this measure equals this measure, right? Okay, then find the length of the hypotenuse. Hypotenuse is the diagonal. And the coordinates of its midpoint. So if I were to label these vertexes of this triangle, we know that is 0, 0, right? We know that this one is, we'll just say K0. And then this one would be 0, K. Okay, so those are my points. You're going to use the distance formula to find the hypotenuse. Do you guys remember the distance formula? So we have the distance between, oh, and they labeled each of these. So this is P, point P, this is point Q, and this is point 0. Oh, like that doesn't confuse anything. So the distance formula, I'm going to find the distance from P to Q. That's the hypotenuse. So I'm going to say the square root of, do you guys remember this?
Yes.
2 minus x1.
Okay, so I'm going to use x2 being, this is going to be my second, this is going to be my first. So I'm going to say k minus 0 squared plus 0 minus k. Yeah, whatever variable you have, it doesn't really matter. Okay, now this is funky because we're solving this with letters. So we're actually not going to come out with a nice, clear, pretty little number, but we will come out with an answer. Okay, so to simplify this, k squared would just be k squared, and then minus 0 squared is 0, so k squared. And then plus 0 squared is 0, so then I have negative k squared, right? Like that. Now I can simplify that and say, what is a negative times a negative? Right, so I can just say this is actually k squared plus k squared. So what's 1k plus 1k equals? 2k, so this would be 2k squared. Okay, and then the very last thing you can do is when you have something squared that's under a square root, they cancel. But I still have the 2 under the square root. So they cancel and you move the k on the outside. So this would be equals k square root of 2. So when you have something squared, you can move it outside the square root and get rid of the squared, and then just leave whatever else is on the inside. So this is my final answer, k square root of 2. Okay, so that's the distance. So that's going to be PQ. That's the distance of our hypotenuse. Okay, now we need to find the midpoint, which would be approximately there, and it'd make these two equal to each other, right? What's the midpoint formula? Do you guys remember that one? It looks like an X and Y. It looks like it's put it in like this. Do you guys remember it? Do you have it written down anywhere? I'm going to turn the page. Okay, remember it's x1 plus x2 divided by 2, and then the y1 plus y2 divided by 2. So that's how you find your 2 points. Okay, and again, we're dealing with variables. So the midpoint of this would be, you would say 0 plus k divided by 2 for the x's. And you'd say k plus 0 divided by 2 for the y's. Well, can you divide 0 divided by 2 on either one of these? No, so you just cancel those out. So your answer is going to be k divided by 2 for x, k divided by 2 for y. So this is the midpoint. I forgot the word, the letter P, midpoint. All right, any questions on that? I'm not assigning any of the proofs for you to do. So all you're going to have to do is find me segment lengths using either the distance formula or the midpoint formula, depending. Okay?
Yeah.
If it asks you to prove or explain anything, it's just like a 1-sentence answer, not a 2-column proof. So this is lesson 5.1. You're doing numbers 3 through 19 and 24 through 26.